Here we have a diagram of a particle that we're told is about to slide down the slope. So it's in equilibrium at the moment, but it's on that verge of moving, which will mean that F will be, the friction will be at its maximum. Now, because it's going to move down the slope, not up the slope, that's why the friction is being directed up parallel to the slope. We've got to work out what P is, what that force is that's keeping everything in balance at the moment. We're going to start by resolving in the perpendicular direction to find out what R is. So R will equal the perpendicular element of the weight. This is 40 degrees, so this would be 50 degrees up here. So that means that this angle is 40 degrees. And because the force we're interested in is adjacent to that, it means that R will be equal to 50G cos 40 degrees. We know F equals mu R because it's at its max. So F will equal 0.5 times 50G cos 40 degrees. Let's just tidy that up a little bit because we can at least write that as 25. So now we're going to resolve parallel. So parallel, we've got P and F acting in the same direction, but we're going to have the element of the weight force acting in the opposite direction. So they're going to balance. So that's going to be 50G, and that one will be sine 40 degrees. So we can see that P is going to be equal to minus 25G cos 40 degrees, the friction force, plus 50G sine 40, the weight element. And if we pop all of that in a calculator, that works out to 127 newtons. We have a new diagram here. We're told this is a vehicle with an engine exerting a force of 120 newtons. And it's accelerating from rest and moves up 4 meters up the slope in 2 seconds. And we need to find mu, the coefficient of friction. We're going to start by finding R, because to find mu we're going to need both the friction and R to find that. We're going to start by finding R by resolving perpendicular to the slope. So R will be equal to this force here, this component of the weight. That's 20 degrees there, this is 20 degrees in here, that's adjacent, so it will be 20G cos 20. So we'll keep that for later because we need F now. So to find F, we're going to need to resolve parallel now. And the first thing we're going to work out is what F net is. So it's moving up, so that's our direction of movement. So it's going to be the force of the engine, which is 120, minus the friction that we don't know yet. And we're also going to have opposing that the force coming from the weight in the reverse direction, which will be 20G sine 20 degrees. And that we know equals the mass, which is 20, times the acceleration. But at the moment we don't have the acceleration, but we do have information we can use to find that acceleration. So we were told that it starts from rest, so that means u equals 0. It's moved 4 meters So we've got s, and we've got a time of 2 seconds, and we need to use those to find the acceleration. So we're going to use s equals ut plus a half at squared. So 4 equals nothing for that first part because u's nothing. So we've got a half a times the time squared, which will be 4. So that means that we've got 4 equals 2a. So a must equal 2 meters per second squared. So we can take that and put that into our previous formula. What we're also going to do is rearrange things because we want to get f on its own. So f will equal 20g sine 20 degrees minus the 120 newtons plus 20 times 2. And if we put that into our formula for friction and rearrange it, we can find that mu will equal that which we've just written down, all over r, which we worked out earlier, with the help of the calculator, we'll find that that is 0.07. Remember, the coefficient of friction doesn't have units.